This lesson is on scientific notation. First of all, we want to talk about why we use scientific notation. Scientific notation is used to write very large numbers or very small numbers in a shorthand form. This down here is a very large number. It's actually called a mole. And a mole, or 6.02 times 10 to the 23rd, is a very, very large number, and it's used in science. Okay, so when we look at this scientific notation, it's written as two factors. So we've got this factor here and this factor here. Remember, factors are two things that are multiplied together to give you a product. So the blank here written as two factors. This factor here has to be greater than or equal to 1 and less than 10. Okay, so it has to be greater than or equal to 1, and 6.02 is greater than 1, and it's also less than 10. So this number has to be between these two values, and it could be 1. Over here, the other factor is a power of 10. So what we're trying to do here is we're saying that if you take 6.02 and multiply it times 10, 23 times, that will give you this actual number. And every time you multiply by 10, remember you move the decimal point over one place value, because place values are powers of 10. So this would be multiplying the number by 10. So if we look at this chart, I'd like to start with this chart right here in the middle where it says 2.35 times 10 to the 0. Well, if you'll recall, 10 to the 0 power is the same thing as the number 1. So really, we're taking 2.35 times 1, which is 2.345. No, 2.345 times 1 is 2.345. So let's go down the chart first. So if we go down and multiply 2.345 times 10 to the first power, that's 10 more than this 10 to the 0. That is 10, that's one factor of 10. When we multiply by 10, we're just really moving the decimal point on 2.345 over one place value. So you end up with 23.45. If we move up and multiply by one more factor of 10 and have 10 to the second power, that's like 10 times 10, or a 1 with two zeros, or 100. 2.345 times 100 means we're going to move the decimal point over two places to the right, and that would make it 234.5. Then if we go multiply by 10 more, then we're from 10 to the second to 10 to the third, so that's going to be 1,000, or a 1 with three zeros behind it. So if we move the decimal point over three decimal places, we'll then have 2,345, because we've moved the decimal point from between the 2 and the 3, times 10, times another 10, times another 10, which is the same thing as multiplying by 1,000. So we have 2,345. So as we move down this chart, and we'll just start from moving down from 10 to the 0 to 10 to the third, it moves one place to the right, it being the decimal point, with each increasing power of 10. And this is saying, notice how the decimal point moves. So it moves two places to the right, or I'm sorry, one place to the right for every new power of 10. So if we go up the chart, then if we start, we've got 10 to the 0. If we move up to 10 to the negative 1, 10 to the negative 1, if you'll recall, negative exponents, that's the reciprocal, or 1 over 10. And 1 over 10 is the same thing. We've done this a lot in mental math. It's like dividing this by 10 when I multiply it by 1/10. So if we divide by 10, we move the decimal point one place to the left. So it was between the 2 and the 3, and now we moved it to the left, behind the 2, to the left of the 2. So now that is 2,345 10,000ths, because the 5 is in the 10,000ths place. So if we move up one more, that's like doing 1 over 10 squared, which is the same thing as 1 over 10 times 10, or 1 over 100. So that means it's like we're dividing by 100, this 2.345. So if we divide by 100, we move the decimal point from between the 2 and the 3, left 1, 2 spaces. Notice there's an exponent of -2, we move it to the left 2. Notice down here, when we have an exponent of 2, we move the decimal point to the right 2. So if we move up to this last one, then that's going to be like 1 over 10 to the third power, which is like 1/1000th. So that means we're going to move the decimal point over 3 places to the left. 1, 2, 3. We move it over 3, 1, where are we at? Okay. So if we move it over 3, instead of just having one decimal place, or 1 0 behind the 2, we're going to have 2 zeros behind the 2. 1, 2, and then the 2, 3, 4, 5. It was here. We go 1, 2, 3. So 10 to the -3, we move the decimal point one place to the left. So let's try some. So our first example down here, we've got 1.35 times 10 to the 5th. So that 10 to the 5th is like 10 times itself 5 times, or a 1 with 5 zeros, which is 100,000. So it's like we're taking 1.35 times 100,000, which means we're going to move the decimal point 2 places for the 3 and the 5, and then 3 more places, so we'll add 3 zeros. So it's going to be 135,000. So it was here, and we're going 1, 2, 3, 4, 5 places to the right. And our comma would be behind the 5. So it's 135,000. If we do 2.7 times 10 to the -3, that's like 1 over 1,000, or 1 over 10 to the third power, which is 1,000. So it's like taking 2.7 times 1/1000th, which means we're going to move the decimal point 3 places to the left. So the first place has the 2 in that spot, and then we're going to go 2 more, so we have to add 2 zeros. So that's going to be 0.0027. It was here between the 2 and the 7. We go 1, 2, there's the third place to the left, because it's -3. 2.01 times 10 to the -4, we could say 1 over 10,000, or we can just move the decimal point 4 places to the left. So if we go 4 places to the left, the first place has the 2, then we need 3 more places with zeros, so it'll be 0, 0, 0, 2, 0, 1. To check it, we go 1 place for the 2, 2, 3, 4. It's 10 to the -4, and we put 3 zeros on there so we can move 4 spots. Okay, so now we've got a really small number, and we're going to write it in scientific notation. So now we got to go back up and remember that it's got to be a number between 1 and 10. It could equal 1. Well, in order to get a number between 1 and 10, we're going to have to move the decimal point backwards 3 spaces to get it between the 7 and the 0. So that's going to be 7.09, which is a number between 1 and 10. Now we have to figure out what we need to multiply it by, so that if we multiplied this by our power of 10, we would actually be moving this decimal point backwards 3 spaces, so that we would have the 2 zeros in front of the 7. So there's 1 0, 2 zeros, and then where the 7 is. So it's actually going to be moving to the left 3 spaces to give us this number. So that's going to be to the negative 3. If it's a very small number, it's going to have a negative exponent because we have to move the decimal point to the left to make it a small number. If it had a positive exponent, we'd move it to the right. Let's read this last example, and that'll show that. It says a pencil is 18.7 centimeters long. If you were to lay 10,000 pencils end to end, how many millimeters long would they be? Write the answer in scientific notation. So it's basically taking 18.7 and multiplying it by 10,000. So that's like 18.7 if it's times 10,000, and we want to write it in scientific notation. Then we're going to have to move the decimal point back 1. When we move it backwards 1, this number gets smaller, so that means this number has to get bigger by another power of 10. So we're going to have, instead of 4 zeros, 5 zeros. So that when we move it the first place to the right, that would give us 18.7 times 10,000. But if we move it 1, 2, 3, 4, 5 places to the right, we will get 187. So let's go 5 places. Here's 1, 2, now 3 more. 1, 2, 3. 1, 2, 3 zeros. So that's going to be 187,000. And you may say, well, why did you have to move it back 1 to write it in scientific notation? Because remember, this number has to be a number between 1 and 10. 1.87 is bigger than 1 and less than 10. And then if we move it back 1, we have to have one more place value here, so it has to have one more 0. So now when we write that in scientific notation, it's going to be 1.87 times 10 to the, there's 5 zeros, so 10 to the 5th. Okay, so how long is it? Here's how long it is in centimeters, 187,000 centimeters, which is 1.87 times 10 to the 5th, a really large number written in scientific notation. Okay, if you need to rewind or go through any of this again, you can. Make sure you've got the notes filled out. Tomorrow you'll come in and do an exit slip in practice.